This is question 23 on the higher non-calculator paper. There's a diagram here and it indicates that it's not drawn accurately. The shape, ABCD is a square. P and D are points on the y-axis. So P and D are points on the y-axis. A is a point on the x-axis. So there's A on the x-axis. PAB is a straight line, and the equation of the line that passes through the points A and D is y is equal to minus 2x plus 6. So A and D. I'm actually going to highlight this line. So there's that line there. That's the line that they've told us is y is equal to minus 2x plus 6. And the question wants us to work out the length, find the length of PD. Now PD is this distance here, P to D. I'm actually going to put that there, right, because that's what they want us to work out. Okay, so what do I know? I know the equation of this line, right? I know this is a square over here, and I know that I want to find P and D. Right, I'm going to try to see if I can work out what A is and what D is. So I've got this equation, y is equal to minus 2x plus 6, and D is on the y-axis. So on the y-axis, x is equal to 0. So when x is equal to 0, right, y is going to be 2 times 0, which is 0 plus 6. So y is 6. So that means this point here, D, is going to be, it's going to have coordinates. So its x coordinate is 0 and its y coordinate is 6. So this point over here is going to be 6. So that means from here to here, from O to D, that is 6 units. So I've worked out part of my answer so far. I'm going to try to work out what A is as well, right? Because I think that could help me with some of these triangles. So to find out A, on the x-axis, right, your y value is 0, so y is equal to 0. I'm going to put that into this equation up here, and I'll get 0 is equal to minus 2x plus 6. Take the 2x across, so I'll get 2x is equal to 6, x is equal to 3. Alright, so what does that tell me? That tells me that the coordinates of A, in this case the x coordinate is 3, and the y coordinate is 0. Just zooming back in on this. Okay. Alright, now what we've got so far is the fact that the coordinates of A, at that point it's 3, that point there is 6. Now I'm going to break this question up a bit further by looking at a couple of the triangles in this shape. So first of all, I'm going to look at the triangle ODA. So if I draw that triangle here, O, D, and A. Now I know the length of this side is 3. I know it's a right angle triangle, and I know the height of this triangle is 6. And this triangle at the bottom, OAP, so OAP, this is another right angle triangle, right? But this triangle is actually similar to triangle ODA. They are similar triangles. And this distance here is 3, right? But a couple of the other things I know about this is that they share several angles. So, for example, this angle at the bottom is exactly the same as this angle here in the shape, right? We could see it up here. This angle at the bottom is the same as this angle here. And the angle at the top is the same as the angle over here. And looking at it in this shape here, that angle is the same as those. So these two shapes are similar. And what it means by similar shapes is that their sides are in proportion. So this side here, O to A, corresponds to this side here, O to D. And I could see going across to there that my multiplier is 2. Okay? This side here, O to P, corresponds to this side here, O to A. And again, remember the multiplier is going to be the same because they're similar shapes. So what do I times by, right, to 2 to get 3? So OP is going to be 3 divided by 2 to find out what number times is 3 to get. So times is 2 to get 3. I'm going to do 3 divided by 2, and that's 1.5. Now what that tells me is O to P is 1.5. And going back to my diagram above here, that means that coordinate there is 1.5. Well, it would be minus 1.5 because it's below the axis. But the distance, the question is asking us to work out the length of PD. The length of PD is going to be 6 added to 1.5. And the answer there is 7.5, and that's what I'll write in my answer space. Now there are a couple of different ways to go about doing this question, right? If I zoom out a bit, you can see the whole thing. There are a couple of different ways to do this question. Some involve Pythagoras, some involve using equations of perpendicular lines. All of them are quite valid, right? But this is one I've just chosen to do. And if I had to do this in an exam, I might use a technique quite similar to this myself. I understand it, I could follow it, right? And I could use the idea of similar shapes to work out the missing distance. Go through this a couple of times yourself. Make sure if you get a question similar to it, you can get full marks.